So this is a run through of the tracker software and how I use it on the spring and cart video that I took earlier. First thing I want to do is import the video in question, and it's located in this folder that I've created. So just click on open it up and it will load. This is a reasonably small file, but I still want to increase the amount of memory used in here. So if you look at the top here, I have clicked on this and changed it up to be 1 gigabyte, just allowing me plenty of room to play, and it makes sure I don't run out of memory. So we're looking at the film. We want to make sure that we only start doing the analysis after I release the trolley, which is about frame 200. So I'll just move this marker to the 200 frame. Which is never as easy as it looks. There you are, 200. The next step is to see where it stops, and that's about here. So we don't need anything after that. So we can move that to about there. The video was filmed on a fairly wide angle lens, so what I want to do is take that into account by taking out the radial distortion. The field of view of the camera was 120 degrees. So I'll put that in there and close. That should take the coordinate system and make life a little bit easier. We're in our stop position, so I've just clicked on the axis, bringing that down. So we have our 0 position. Click on again and that will take it away. Next thing to do is to add a new calibration stick. To do this, I'm going to roughly find where the 70 centimeter mark is. Shift click there, and the 15 millimeter mark, 50 centimeter mark, sorry. Shift and click there, and just to make sure that we've got it, we'll zoom in and adjust. That wasn't too bad. That wasn't too bad either. So that's set up. I just need to change the units to be 20 centimeters, 0.2 millimeters, 0.2 meters, and that's set, ready to done, and we can take that off. Go back to the to-fit image. The next thing we need to do is to start thinking about tracking. Right, for the tracking we now need to go right back to the beginning of the video. Click on track, new point mass. Now I don't actually have the mass for this, but we could find it out and put it in afterwards. But we're more interested in just monitoring the position at this stage. Right mouse click on that, and it comes down with the drop down menu where I want to click on our auto tracker. If you look at the instructions over here, bring this on so it's in frame. It says to create a new keyframe, shift control click the video feature of interest, mouse over the controls. The video feature we're interested in is the dot in the center. This gives us a nice contrast because it's red and white. So although the red channel is going to be saturated, the green and blue channels are going to provide us with sufficient contrast for us to follow very easily. So Shift Control click, that finds it, and what we need to do is go back to the keyframe, and it's just dragging that back to the keyframe. Let's move this to one side a minute, and let's zoom in on the target that we're looking for. I'm dragging this circle as a really large target, but I'm trying to drag it over it so it's looking for trying to get some image around the outside of it as well. So you can see in this what the target's looking for and what it's accepting. Go back down to 50%. That's going to be our better object. So that's what we're looking for, and if I click search, this should do an automatic search. But the first object is not where we want to, so I'm going to ask, if you look at here, accept match, modify searcher and search again. Shift click to mark manually. So shift and click. Again. And now it's actually beginning to track all on its own. So that first one was a bit of an anomaly. And you can see it's going through and marking as it goes. This bit of the video will probably be sped up. As you can see, this has now come to a stop, so we can just wait for the last few frames to count through. Processes. So all marked. So that's done. We can close the search box, and we have our data here. Just to show you that we've got the data, we can show the velocity in the x direction. This is all sort of stuff you can play around with later. The acceleration. But what's more important for us at the moment is looking at the data below. Before I do anything, I'm going to save this. Save tab as trolley springs track save. The next thing I want to do is take this data and export it to Excel or to a CSV. So we want to export this data we have here to Excel. So we'll just click on the top column there. Right, so to do that, it's not quite as straightforward as you would hope, but consists of exporting it. So export data file. That is the data we're looking for. We're wanting to do all cells. If you only do selected cells, you'll only get the values that you wanted. So it could only possibly be, say, the first 2 rows or so. Full precision isn't necessary. It might be too large. As formatted is probably the best bet. And the delimiter, I would suggest a comma separated variable. We now want to save this, and we'll give it a suitable name, car spring data, and we'll give it an extension. Hopefully this will be taken across. The default for this save is not anything normal, so it's a good idea to try to preempt that, and we'll be able to find the CSV string in that an awful lot easier. So that should be the file saved. So we now need to open a blank Word book in Excel and open the file. So want to browse. This is where having a logical format to your data storage would have helped, but that's not how I have done it, so I'll have to suffer consequences of my lack of pre-planning. And it's in that folder there. As you can see, it doesn't appear to have located the file we want initially, but if we click on all files, car spring data is there, so we can open that up. Okay, let's have a look and see what the data's like. Data. Actually, I want to insert a chart to see what the spread is, and that's exactly what we're after. So I'm going to now try to find the outer edge, the envelope for the decay. So first thing I'm going to do is copy this data A and B onto a new sheet, and what I want to do is, starting here, we want to look at the differences in values between the value and the value prior to it. So I copy that down, and you can see 270 odd value pairs. Now imagine doing that by hand, it will take a long time. With that done, we need to look and see what the value is of the turning point. And that occurs where the value, the difference between the two goes from positive to negative. So we want to return we're going to need to set a let's call this delta, this one delta, and we're going to call this one a flag. The flag is going to be generated using a logical statement, and it's an if statement, but there's two conditions to be met. So I need to use an AND, a logical AND statement. Now the logical AND in this Excel comes before the testing, which is unlike most other languages. And what we're testing to see is if the change C4, so in brackets, if C4 is negative, so it's less than 0, less than 0, and C5 is positive, or basic 0 or positive. the value we want to return, the value if true is a 1 and the value if not is 0. So I've actually got the negative side of that, so I need to force those around the other way around. So that's, you see, that is the most negative. But that's not a problem. So I can do that. I'm back up to here. So if C5 is greater than 0 and that's more like it. So that's got the upper peak. So as you can see, you can use the method to get the envelope on the base. So we're now going to extract our B positions now. To do that, it's yet another if statement. That won't work until I put equal sign before it. Here the logical test is a lot more straightforward because we just need to take our value D4 and set it to 1. So D4 equals 1, the logical value, if it's true, we want to return the value of B4. And the value we want to return if nothing's there is basically an empty set. So I think the value is NaN, not a number. That's like it. So bring that down. Check. Okay, so now let's see. Right, so if we now highlighted those two columns, and this one, insert, looking for a chart, and as you can see, we've got two series, one with the x values and one with the peak x values. So from the data here, you can see that we've got a spurious red point at 0, 0. So to change that, right mouse click on the data, click the select data button, edit that, change where the X data comes from to be all below 0. So y, it's got to be from again. I want to edit that. If I'd been sensible, I would have just kept the values. With any luck, we'll have that, but without any axis titles. We can always add that later. And there's no blue line there. If I now click on the top point and right mouse click, I can add a trend line, go for logarithmic, and see that the line works quite well. Display equation. So it's not a perfect line, but it definitely does show the trend. I think there was a bit of motion on the track as it was rocking backwards and forwards, but it's not a bad solution to that. Obviously, you want to change all the chart title and everything, but this is just to show you the method you can use to generate this equation for this periodic log decrement of the waveform.